welcome to today's deep dive. So we've got an incredibly fascinating stack of sources to go through today, all about, well, a topic that literally changed the world of tech. But before we get into the math of it all, I want to ask you, the listener, a question. Have you ever noticed how your attention just gets completely stolen by something while you're, like, scrolling on your phone?
Oh, yeah. Like when you open an app just to check a message and suddenly you're watching a 20-minute video about, restoring old furniture.
Exactly. You didn't mean to look at it. Your brain just kind of passively surrendered to whatever was flashing on the screen. It's a biological hack.
Yeah.
But the AI systems we're talking about today, they have attention too, only it works entirely differently.
Right. Because human attention is often passively stolen, but AI's attention is mathematically calculated. It is highly intentional. And that's our mission for today's deep dive. We're going to completely demystify this mathematical mechanism.
Yeah, because this mechanism, attention, with a capital A, is literally the secret engine behind the most powerful modern AI models out there today. Everything from ChatGPT to, well, basically the entire generative AI boom.
It really is. And to understand it, we need to look at what attention is at its absolute core. At its most basic level in machine learning, attention is just a method for extracting what is important from a massive, pile of information.
Right. It's not about reading every single word equally.
Exactly. It's about applying a weighted reading to data. There's this great analogy in the source material about being in a business meeting. So imagine you're in a room and there are 10 people talking all at once.
Which sounds like a total nightmare, by the way.
Right. Total chaos. But your brain handles it. You don't listen to all 10 people with equal focus. You naturally tune in to, say, your boss or maybe the person who is specifically talking about your team's KPIs.
Yeah, you just automatically filter out the guy talking about what he had for lunch.
Exactly. Your brain assigns a high weight to the boss's voice and a near zero weight to the lunch conversation. That is the essence of attention.
Which is such a massive leap from how AI used to work. Like, the sources gave a lot of historical context here. Before attention came along, AI mostly used these things called recurrent neural networks, or RNNs.
Yeah, the old industry standard for natural language processing.
And they really struggled, right?
Yeah.
Because they read text chronologically, word one, then word two. So they inherently favored the most recent words and just kind of forgot the earlier ones.
That's the vanish ingredient problem. By the time an RNN gets to the end of a long paragraph, it has completely lost the context of the very first sentence.
But attention fixed this entirely. It allowed the AI to basically jump around and directly access any part of a sentence equally. No matter how far apart the words are, the main point actually remains the main point.
It completely leveled the playing field. And the way it achieves this is through an architecture built on 3 pillars: the query, the key, and the value, or Q, K, and V.
Yes, QKV. Whenever you read about transformers, you see these 3 letters everywhere.
You really do. And the sources break this down beautifully with a restaurant scenario. Let's say you're looking for something specific.
Okay.
The query is who or what you're looking for. It's the question.
Yeah.
Like, I need a waiter who can take my drink order.
Got it. So the query is my demand.
Right. Then you have the key. The key represents the visible features or the labels of everyone in the room. So you look around and you see someone holding a tray, wearing an apron. Those visual cues, those are the keys.
And then the value is the actual payload, right?
Exactly. The value is the actual person, the waiter, and the service they provide.
I love the other analogy the sources brought up for this, the blind date, or like a matchmaking market.
Oh, that's a really fun one, yeah.
Yeah, it makes it so intuitive. Imagine a room full of people. Everyone is holding up a sign with their keys, so their profile, their hobbies, whatever, just waiting around.
And they're waiting for someone's query to come along and match with them.
Right. The query is someone walking in saying, I'm looking for someone who loves hiking and dogs. And if the query matches the key on someone's sign, boom.
It's a match.
A mathematical match.
Yeah, and then they finally exchange values, which is the actual conversation, the real deep information. But that brings up a really big question for me.
Okay, lay it on me.
How exactly does the AI calculate this match? I mean, mathematically speaking, how does it do this without just being totally overwhelmed by data?
That is where the elegance of the math comes in. The core mechanism here relies on calculating similarity, specifically using something called a dot product.
Okay, the dot product.
Yeah. The model literally multiplies the vector of the query by the vector of the key. And in linear algebra, a higher dot product simply means those two vectors are pointing in roughly the same direction.
Meaning they are highly similar.
Exactly. Similarity equals weight. The higher the similarity score between the query and the key, the higher the attention weight that gets assigned to that pair. So it generates all these raw scores. But raw math numbers can be super messy, right?
Extremely messy. They could be negative, they could be massive. So to make sense of them, the AI passes these raw scores through a softmax function.
Right, the softmax. I always picture that as like a percentage converter.
That's a perfect way to look at it.
Yeah.
It turns those raw chaotic numbers into a neat probability distribution, like a voting system where not every vote is equal, but at the end of the day, everything has to add up to exactly 100%.
Okay, wait. I want to jump in here and push back on just the raw softmax thing, because the sources highlighted a crucial mathematical trick here that I think is brilliant.
Oh, the scaling factor.
Yes, scaling by the square root of the dimension size, the Chalky-Taller thing.
It is arguably the thing that makes the whole architecture physically possible.
Right, because if you don't scale it, if you just take those raw dot products and throw them into the softmax function, the variance just explodes as the models get bigger.
The numbers get way too large.
Exactly. And when you feed astronomical numbers into a softmax function, it completely breaks. It acts like a hard max. It just fixates on one single word, gives it 99.9% of the attention, and completely ignores everything else.
Which defeats the entire purpose of reading the whole sentence.
Right. So by scaling it down, dividing it by that square root, it keeps the math stable. It ensures the AI's attention remains appropriately distributed across multiple words instead of just totally obsessing over one.
And that distribution is everything. It's essentially calculating what we could call affinity. It's determining the fate of the sentence, deciding exactly which words are destined to interact with each other and share meaning.
Which brings us to the coolest part, in my opinion. What happens when a sentence needs to analyze itself?
Self-attention.
Yes, because everything we just talked about is sort of regular attention, but self-attention is the real secret sauce.
It is. The sources use a really classic natural language problem to explain this, the pronoun problem.
Oh, the Xiaoming example.
Yes, exactly. So the sentence goes, Xiaoming hit Xiaohua because he was angry.
Okay, so Xiaoming hit Xiaohua because he was angry.
Right. Now, for a human, it's obvious who he refers to. Xiaoming was the one who hit, so Xiaoming is the angry one. But how does an AI know who he is?
Because he could technically be either of them.
Exactly. In self-attention, the model doesn't just read left to right. Every single word in that sentence calculates its relationship with every other word in the sentence, including itself.
That is wild to think about.
So Xiaoming looks at Xiaohua, angry, looks at the entire sentence to figure out who it belongs to. And the word he runs its query against the keys of every other word, and it figures out its strongest connection is to Xiaoming.
It's like, okay, think of a traditional classroom. The old RNN model was like a teacher calling on one student at a time. Okay, word one, your turn. Now word two, your turn.
Very slow, very sequential.
Right. But self-attention is like taking that entire class and dropping them all into a massive Discord server. Everyone is talking. Everyone can hear everyone else's input instantly and simultaneously.
I love that. A mutual understanding network.
Yeah. It turns the sentence from a line of words into this deep, interconnected web of context. Which leads to the obvious question. Why is this so powerful? Why did attention literally take over the entire AI world?
The sources outline three main advantages. The first is long-range dependencies. Like we said, words at the beginning of a paragraph can directly link to words at the very end. The information never degrades in the middle.
Right, no vanish ingredients.
Exactly. The second reason is parallel computation. Because the model processes the entire sentence at once, rather than word by word, you can train it across massive clusters of GPUs simultaneously.
It's optimized for modern hardware.
Completely. And the third reason is flexible information selection. The model dynamically decides exactly who and what to look at based on the context of the prompt.
You know, it reminds me of the stairs versus elevator analogy from the reading.
Oh, yeah. Break that one down.
So the older RNN models were like walking up the stairs, right? One step at a time, very exhausting. You had to hit every single step to get to the top.
And you forget why you started climbing by the time you reach the 5th floor.
Exactly. But attention is like just stepping into an elevator and pressing the exact button for the floor you want. The speed and the efficiency of that direct connection, it's completely game-changing.
It's a great analogy. But here is where it gets even more complex. Because looking at a sentence from just one perspective, well, it isn't enough. language is messy.
So true.
So the transformer architecture uses something called multi-head attention. It takes that exact same sequence of words, but it looks at it from multiple different angles simultaneously.
This part blew my mind a little bit. It's like a corporate board meeting, right?
Yeah, that's a good way to frame it.
Because you don't just want one person making all the decisions.
Yeah.
You have one head that acts like the grammar department. All they care about is the verbs and the nouns.
Right.
Then you have another head acting like the semantics department. They care about the actual meaning. And another one tracking the emotional tone. They are all analyzing the exact same sentence, but they're answering completely different questions.
And then at the end, they pool all their separate insights together into one final vector. Because one brain just isn't enough to capture all the nuance, so the AI uses multiple distinct angles.
It really highlights what a massive paradigm shift this was. Like, the sources make it clear, this didn't just improve AI a little bit. It sparked an absolute revolution.
It really did. It gave us BERT. It gave us the entire GPT series, and it didn't even stop at text. This exact same attention mechanism expanded into image generation and speech recognition.
Vision transformers, right?
Yep. It shifted the entire philosophy of AI from trying to aggressively remember the world to dynamically selecting the world.
Okay, but we have to talk about the dark side of this. Because the sources specifically point out that all this magic is not free.
Oh, it is definitely not free.
There's this thing called the quadratic trap. The big O of n squared problem. All of Ehlers.
The bane of every machine learning engineer's existence.
Right, because attention requires every single word to look at every single other word. So if your sequence gets longer, the computational math doesn't just double. It explodes quadratically.
It really does. If you double the number of words, you quadruple the amount of math required.
And more importantly, it just eats up a massive amount of physical GPU memory, right?
Oh, yeah. The memory footprint is astronomical. While attention is incredibly smart, its computing bill has a very, very strong presence.
So how do they even run these massive models with million token context windows?
Well, researchers are constantly trying to fix this cost. They use methods like sparse attention, where the model is forced to just completely ignore irrelevant tokens to save space.
Oh, I see. Just don't even calculate the math for the useless stuff.
Exactly. Or they use things like KV caching, where they save the older keys and values in memory so the model doesn't have to recalculate the whole conversation every time you ask a new question.
Wow. It's basically a constant battle between this elegant math and the physical limits of computer chips.
That's exactly what it is. And, for you listeners out there, especially if you're a career changer or just getting into the deeper tech side of this, do not let this complex math intimidate you.
Yeah, the formulas in the sources look terrifying at first glance.
They do. But you don't need to memorize the formulas to understand the shift. Just remember 3 core things.
Okay, what are the 3?
First, attention is just weighted selection. Second, the Q, K, and V setup is simply a matching mechanism for search.
Like the blind date.
Exactly. And third, self-attention is just global relationship modeling. It's just the sentence figuring itself out.
I love that. So to summarize it all, attention is really just an advanced form of feature selection. The AI isn't actually trying to look at absolutely everything all at once.
No, not at all.
It's just learning what it can safely ignore, which is such a profound concept. Focusing effectively is so much more important than just having a massive, perfect memory.
It is. In fact, that's a perfect philosophical takeaway to end on today. The source material hints at this underlying truth. Human intelligence is built on our lived physical experience. AI intelligence is built purely on data.
Right.
But the true shared wisdom of the attention mechanism, whether it's inside a human brain or a silicon chip, is knowing exactly what to ignore.
Wow.
In a world of absolute information overload, not every single piece of information is important, and not every voice requires a response.
That is something really profound for all of us to mull over on our own time. Because as these models get smarter, their ability to ignore the noise is only going to get better.
Absolutely.
Well, that wraps up today's deep dive on attention. Definitely stick around because we're building on this. Our next custom deep dive is titled From Transformer to Generative AI, where we're going to explore what happens when an AI takes this exact attention mechanism and uses it to start actually creating brand new things from scratch.
That is going to be a fun one.
It really is. Thank you so much for joining us for this deep dive, everyone. Make sure you subscribe to the channel so you don't miss the next one. See you next time. Cheers.